Okay, good afternoon, good morning, good evening, wherever you are around the world. My name is Julian Stuhler. I'm one of the directors of Tran Consulting. It's my pleasure to welcome you to the second of the 4 webcasts that we'll be conducting over the next few weeks, all around the new version of DB2 for Linux, Unix, and Windows, DB2 11.1. Last week's webinar with George Backlars and Iqbal Gorawala of Triton looked at a general packaging and technology overview for the new release. And this week we're going to be zooming in on one of the specific sets of new enhancements inside the new release, and that's enhancements around the BLU technology. So without further ado, I'll hand it over to George and Iqbal. George.
Yeah, thanks, Julian. Welcome, everybody, to this session on DB2 version 11 and BLU enhancements. We hope you liked last week's session. Today we're going to dive a little bit deeper into BLU and the things we've done with both the BLU technology and BLU MPP. So before we get started, Iqbal, do you have any comments about last week's session or any additional questions you wanted to go through?
Sure. Thank you, George, and welcome everybody to today's the first deep dive in this series of webinars we have on DB2 11.1. My first question to you, George, is where in the world are you today?
I'm not home. I'm in Raleigh-Durham today, which is, many of you know, that's kind of on the East Coast, and actually we've been getting hammered with some very wet weather lately. So I was lucky to get in early last night at about 1 a.m. So I'm bright and fresh now to be able to do this presentation.
Okay. Just checking.
Yeah.
Okay. I think for me last week, it was a great presentation really. I just wanted to quickly summarize what I took away. For the benefit of everybody who has joined in, and for those who are newly joining in today. Of course, the session is available for download. It has been recorded. But what I took away from last week for DB2 9.11, the first thing I took away was really the ease of adoption of DB2 9.11. You can now directly upgrade from 9.7, 10.1, and 10.5. That means 3 releases down, and this is the first time that IBM has done it, and it's fantastic. I think it will be a big welcome for many, many customers. Secondly, we came to know that there is no express edition in DB2 11.1. However, this just simply means that DB2 Express users are actually the winners. They automatically get upgraded to Workgroup Server Edition, which means they can use up to 16 cores and 128 gigs of memory to play with. In terms of the upgrade process, I felt that this is the first time really, and again a very welcome sort of enhancement in terms of availability during the upgrade. So, as George mentioned last week, you don't need to take any offline backups to do the upgrade. Of course, you need to be on DB2 10.5 Expect 7. But once you're there, you don't need to take any offline backups. Online backups will suffice. Secondly, if you are using HADR, the standby now does not need to be reinitialized using backup and restore. You can simply upgrade the standby online. The other takeaway was for both WSE and ESE, not the advanced edition, but your normal editions. You have federation included, you have encryption included, and you also have pure scale included. And this is the 2-node option that George talked about, with the second node being used as an admin node. The licensing for the second node is simply 100 PVUs, similar to the HADR standby. So that's really, I think, massive really for people on WSE or ESE who want to start using pure scale and they can quickly uptake that. Also, TCP/IP connectivity is allowed for this 2-node option. The next goodie really was the direct editions. These are new editions. They're called the direct editions for both cloud and on-premise usage. The big thing here is that these are licensed according to a virtual processor core and sold as a monthly license charge. So for quick project development projects, I mean, this is really a good addition to use. Pure scale, we have a deep dive of pure scale next week, but George talked to us about, gave us some teaser of how easy it is to install now in terms of HADR with PureScale, the NeoSync and the sync modes are also supported. And lastly, of course, the big news in this release is the support of BLU with MPP, and that's where we are taking the deep dive today. Okay, so I just wanted to summarize this, and if there's anything that I've missed out, George, or something you want to talk about last seminar that you want to change or missed or whatever, take it on.
No, that's great. Thanks. You could do my next presentation for me. All right. This is a safe harbor statement. We do this every presentation, saying that things could change. As you know, DB2 11 was announced on April the 12th. General availability will be next week, June the 15th. So I'm crossing my fingers that everything's going to come out as we expect. One thing I actually have to mention is that last week we presented the platforms that we support for DB2, and there's a variety of them, the Linux and Unix stuff and etc. One of them that I put on a slide is actually changed. So we mentioned that Red Hat 7.1 and I think it was 6.7 are supported, which they are. Also CentOS, and CentOS, as you know, is a binary compatible version of Red Hat. But we're not going to have official support for CentOS for production systems, which means basically if you're running a DB2 on CentOS, you really need to do it on Red Hat to get support. So that's one thing that's changed from the prior week's charts. So CentOS is not officially supported platform, but it is, binary compatible with Red Hat. So just one thing you should be aware of. Okay, let's talk about what things that are happening in BLU. So the big one that Iqbal's already covered mentioned was the massively parallel processing, or MPP support, with BLU. So we're going to get into some details about BLU itself, why you want to use BLU in an MPP environment, what changes you have to be aware of. We're also going to talk about performance improvements in BLU, some of the SQL that's been pushed down, a couple of Oracle compatibility features, a little more details on what that is. The SQL functions have been optimized to work in Columnar, because believe it or not, not everything worked in Columnar. What I mean by that is that your SQL would run, but the Columnar engine couldn't do some of the functions in a column mode and would have to move them over to the row side, which obviously is more inefficient, right? There's some security enhancements for BLU tables, and also some things we've done with the dictionary. So these are the compression dictionaries that you need to be aware of. Okay, so let's get to why massively parallel processing. So why we care about MPP is because the more servers we can have, or CPUs we can have running against that particular job stream, the faster we can get it done, right? So basically the picture shows, right, and it tells 1,000 words, right? I can get stuff done much more quickly if I can move stuff across a number of systems or servers. So BLU, when it was first designed, really worked on a large SMP box, and that's as big as you could scale. So you buy your 48-way machine, right? That's as big as I could get. So that limited the sizes of databases that you could really run on BLU. If you remember when we first came out with BLU, we kind of recommended 10 to 20 terabytes was kind of the maximum size for BLU to run against that database, right? Anything bigger than that, you had to look at stuff like what's your hot data, etc. So there were limits, right? So I don't know, Iqbal, if you had many customers that are running MPP in your your customer set.
Yes, we do, and as I mentioned last week, we are pretty excited with one of our customer showing interest in moving to BLU, and hopefully this quarter we are hopefully trying to engage with them to do a POC on this.
Right. So there's a lot of interesting things that goes behind building an MPP system. So if you see on the picture here, if you're the only person doing the work, I'm sure you're coordinating yourself, right? Whereas on the right-hand side, you got lots of people or lots of things doing work at the same time, and hopefully they're coordinated. So there's a lot of work that goes into building an MPP system that works really efficiently. So there's a lot of work behind just getting Columnar to work in MPP. So MPP basically says, rather than just running on the cores that I've got with a single instance, I can break that down by moving the data across multiple servers or logical instances, having each server do its own work. And the advantage from the original design advantage for this was in a row-based system. Each one of these servers has its own indexing, has its own logging, has its own scans going on. So each one of them is independent. So they're not, interfering with one another when the workload is taking place. So that means I can really double, triple, my throughput by spreading the data across a number of these servers. So that's how the row-based DPF was designed many years ago. And customers use this for massive warehouses. And they got all sorts of efficiencies by doing this. Of course, there is a complexity involved, right? Because I'm going to have to distribute the data somehow. But aside from that, I found that we got, massive improvements in performance, and you got scalability. You actually got linear scalability by breaking your data up across all of these different servers. Remember, the data is not shared, right? They're not all going against the same set of disks. They all have their own disks, their own logs, their own memory, everything. So that's why you're getting the scaling, because as you scale the data, you're also scaling the servers and everything else that goes with it. So MPP is a great approach, right, for large, divide and conquer large amounts of data.
Yeah.
So that's what we've done with BLU, right? We've basically said, BLU columnar, right, in memory, great for an SMP box. Now we're going to give it to you in a DPF or in a partitioned environment. So that means we allow you now to split up your data across multiple servers. Each one of them runs in memory, BLU processing. So massive scaling changes, right? Instead of having tens of terabytes and perhaps hundreds of cores, we can now go across many, many more machines and have thousands of terabytes, running across the cluster. So overall, you're getting a huge improvement in scalability.
So, hey, George, quick question for you. If my customer, so let's take my customer who has got DB2 DPF, as I just mentioned earlier. Should they consider collapsing it into a single instance of DB2 with BLU, or stay with, MPP and BLU? Is there a rationale for going into a single instance?
Yeah, that's a good question. Actually, we had a number of customers who thought it would be great to get rid of the complexity, right, of the MPP environment, because it is more complex, right?
Yeah.
And they looked at doing things like collapsing it into a single, DB2 BLU image. So what you have to consider when you do that is, first of all, the size of the machine, because, again, a single instance is only as big as the size of the SMP machine. So can you fit it onto one box? And the second thing is the amount of data that you've got. So we used to say the sweet spot of BLU was between 10 and 20 terabytes. The reason we said that is when you compress it, you get down to about 2 terabytes of data, so 10-to-1 kind of compression. And then, if you had to scan that much data, we can do it fairly efficiently. So what you also need to look at is your hot data. So a customer may have, let's say, 100 terabytes of data. That compresses down to 10 terabytes, but I may only be looking at 1/10 of it. So that's a terabyte of data. Right. So that still is kind of in the sweet spot. But what you lose when you go to a single instance is all of the parallelism with utilities, with logging, and with the scripting that you may have created. And that's something that a customer has to consider. I may already have all of my utilities set up to distribute data across my partitions, and my jobs may be built based on what partition the data is in. So you may end up rewriting a lot of stuff. So staying in an MPP environment, it may be easier just to upgrade to BLU rather than trying to collapse it.
Yeah. So I mean, again, I guess you hit the bang on, really. I think it's more to do with the application, really. I mean, if the application itself is got the DPF code embedded in it quite a bit and would require a lot of time rewriting it, then I think it would just make sense to upgrade. And I'm sure you'll talk about the upgrade process, or how easy it is to upgrade to DPF and BLU, rather than just collapsing the whole thing into one instance and then rewriting the application and everything, which probably might be a showstopper for many people.
Right, exactly. The other thing you also have to look at, and you'll see these in the later slides, is when we talk about the requirements for BLU. So some people may have taken a large box and just split it up with LPARs, right? They just virtualized a bunch of systems. So each one of those virtualized systems has an OS associated with it, has memory associated. So there's a certain amount of overhead. So you lose some capacity when you create these virtual LPARs. So collapsing into BLU will save you a bunch of memory and overhead that you're imposing because of these logical LPARs. So that's another thing to look at, right? Can I gain back some capacity in memory? So that might be another reason to collapse BLU. But again, a lot of it depends on the size of your system and whether you have extensive scripting that would require rework going to a single image.
Okay.
All right. So MPP architecture, pretty simple. You know, we've just taken DB2, we put it on multiple servers or LPAR, so each one of them has an OS, has a DB2 instance running, and then what the database is actually distributed across all these nodes. So each node will have a portion of the database. So we do this by hashing. You know, we take the data, we split it evenly, if we can, across all of these nodes. So every node is independent from an operational perspective. And in some cases, we'll have to move data between nodes when we're doing joins, etc. So there are things like, you know, co-location strategies that you have to think about. Where should the data sit? How should it be distributed? What tables should be distributed the same way? But in any case, when a query runs against this cluster, it doesn't matter where it goes in, the query will be distributed to all the nodes, and each node will do the work, right? And then it will combine the results back to the coordinator node, where it started off. So the idea is I divide and conquer, right? So each one of those nodes will do the same query, will do the same work. And by the way, we're smart enough to figure out things like averages require, you know, a consolidation from all the nodes before we calculate it, right? Otherwise, the results will be incorrect. So it doesn't matter. Your SQL doesn't have to change. It's just that under the covers, we distribute the SQL to all the nodes to do the actual work.
So are you saying then that the requirements for DPF in BLU remain the same as DPF in raw format?
They may actually change. Okay, so I'll give you an example. In DPF, you may have created an LPAR with, say, you know, a couple cores, right? With BLU, you know, we can certainly use a couple cores, but BLU really likes parallelism and cores. So we may recommend that you try to put BLU onto an LPAR that actually is on one socket. Okay, so if it's possible, let's say you have a server that has 4 cores per socket, make an LPAR that just takes that one socket, because BLU can take advantage of things like you know, the different caches that are on the socket itself, because there's level 1, level 2, and level 3 caches, right? In some cases, level 4 caches. So the efficiency on a socket is much better than, say, having individual cores. So that may be one design change when you go into into different LPARs.
So I mean, is it safe to assume that whatever the requirements for BLU are on a single partition, on a single server, that's not DPF, just a single server, single instance, those would be the same for each partition in a DPF environment?
Yeah, it could be. What we would probably do is take a look at what we think the BLU sizing would be for us an SMP, and then we look at your DPF and see if the same memory requirements can go across all of your logical partitions. So for instance, BLU likes memory, right? I mean, what database doesn't like memory? So you know, our regular, you know, we would usually say we want between 8 and 16, you know, gigabytes per core, right? 16 gigabytes is per bet, right? So you look at your LPARs that you may be running with DPF, and do you meet those requirements? If yes, good. If not, then you may want to consider more memory, right? Now we always run with lower memory. It's quite possible. You just may not be getting as much throughput as you could if you were running with slightly more memory, right?
Okay.
Okay. Okay, so this gets down to data distribution and stuff, right? Today, in the old version of DB2, we could do distribution by a hashing function. So basically, we try to create a normal distribution of the data so that it's uniformly distributed across all of the nodes, right? So you want uniform distribution, and we use a distribution key. So when you create a table, you tell us what column to use, and that typically is either the primary key or a couple keys associated with that particular table. There's some new things that you can do now with BLU. You can also say random. So that says that we'll pick, you know, what kind of key to use, whether it's unique or by generation, okay? But anyways, you have to figure out what kind of key you want to use.
So, I mean, George, this sounds a little bit scary to me, the random option for distribution. Do you really want DB2 to pick the partitioning key for you, considering you know your database, you know your, so Can you just shed some light on this?
Well, the thing is, if you're a good DBA, and most DBAs are good, except maybe if they work on other products. But anyways, DBAs usually know exactly what key to use, right? And we also have some utilities that can look at your distribution and kind of tell you what would be a good key. If you say random, it may be for situations where, let's say you're using a cloud image, right? Or you're creating a small system and you want to just say, listen, just for testing purposes, let's just do it by random, right? So we don't have to do any work. That may be one option. Or if you feel that there is no good one column, right? You may look at a table and say, I don't know which one is a good distribution key. So what we'll do is we'll kind of look at it from a schema point of view and data point of view and say, you know what, this might be the best column. So we'll do some analysis against it and then decide. Okay, so it's usually in cases where you don't have a clue which one would be a good partitioning key. Okay.
Okay.
But back to your comment, if you're a good DBA, and they'll be able to figure it out in a few minutes, which is a good distribution column.
Okay, cool.
Or they can hire you, in which case you can go in and analyze it for them, and then
I'll be delighted. Absolutely.
That would probably be the better approach, right?
That would be the least random approach, yes.
Exactly. All right, so so here's some column choices, right? You can do primary key or a unique constraint is good, right? Or a subset. You can have multiple columns that are part of the key. The other options are, look for. That dog's not happy with that unique constraint anyway, but we can use data distribution across the cluster. Right, like look for something that evenly distributes it, or look for something called co-location. So this is important because if you have something like star schemas or snowflake patterns in your warehouse, there are going to be certain keys that are used between tables. And so what you want to make sure is that tables that are joined together almost all the time, that their distribution is the same. So what that allows DB2 to do is when it does a join, the tables are co-located, meaning on the same distribution on the same node. That means the joins are very efficient because I'm doing it on the same node. If tables are not co-located, that may result in data having to flow across the different nodes in order to do joins properly. And so we do have efficient mechanisms in DB2 to do that. There are lots of techniques. I'm not going to go into them, but that's not necessarily a really bad thing. It's just better if you can find ways of co-locating tables. Sometimes what things come up like lookup tables, right? And we can distribute lookup tables across all the nodes, so they end up being like co-located joins. So we do look for opportunities to co-locate tables if possible.
Okay.
All right. Okay, so I got a couple things. Choose columns that result in uniform distribution. The more distinct the distribution keys, the better. That makes sense. Try to avoid keys that are very small cardinality. True, false, yes, no, male, female, right? Actually, in California, there's 5, right? Did you know that? There's male, female. No, true. If you get your, driver's license or whatever, it says male, female, male to female, female, male, and undecided. Okay, so it's just they have different distribution there. But it's just that the idea though is to try and get something that's got more more values, not a very low cardinality, right? And select as few columns as possible. So a lot of design decisions. This is no different for BLU than it is for a regular DPF system, right? So there's some decisions you'd have to make.
Yeah.
Okay, so here's just an example of what happens. If you don't have a very good distribution strategy, you may find that some nodes are heavier weighted than others, whereas if you have a good distribution, you'll see it's a more evenly distributed set of rows, and you get a better balanced distribution. So that's all we're looking for when you create a table in a DPF environment. Okay, and when we talk about join performance, you look for co-located keys. So that means that the joins can be done locally. Otherwise, I may have to ship data among the different nodes. So as you can see, common practice is to co-locate rows from the fact table from the largest frequently joined dimension table, and that will result in good performance. So you can see that people who put BLU or DB2 on a single SMP, you don't have to make these decisions, right? Because everything is on the one server. When you start partitioning data and putting it across multiple servers, you're going to have to start looking at these design decisions because they'll impact on how join works. Now, surprisingly, what we typically tell customers is that if you have a a star schema, just following this best practice of co-locating rows from the fact table with the largest dimension table generally results in the best performance anyway. Okay.
Right.
Iqbal, do you get involved with a lot of DPF design at all?
On and off, not too much lately. But I think really the fact that we have got BLU now on DPF, I think that's such a motivator for me to push not only just not only push the BLU technology, but also obviously push the DPF technology, which is as we know, it's a fascinating sort of technology for large scale out. So
right.
so I think this is a fantastic motivator really.
Yeah. Good. Okay, so here's just an example of what happens when you have table joins in 3 nodes. So what you see here is a picture of 3 different nodes. Remember, these are separate servers or LPARs running DB2, their own instance, their own database. The difference is that the database is hashed across all of these nodes. So when we do a join, you'll notice the order table and the customer table are in the same partitions. Each one will have a portion of the data.
Yeah.
I can do the joins locally if they're co-located. So this is a good thing, right?
Yes.
Right? And that's what we want. So that's why design is important, and that's why you need, Iqbal's expertise to come in and take a look, right? And you can do this yourself, of course, but, now, if we didn't have co-location, we do something called data shipping, okay, which basically means that we have to move data between the nodes. We have efficient ways of doing this, but you try to avoid shipping a lot of data. A good example would be something like a lookup table, which could be fairly small, right? So maybe a couple hundred or 1,000 rows. DB2 has techniques that will actually ship that table to all of the nodes and have it sit in memory and be used locally, so it looks like a co-located table. So, don't go wild trying to co-locate everything. Lookup tables can probably just go on one particular node and then it'll be transmitted to all the nodes for lookups, right? But for the larger dimension tables and for your fact tables, yeah, you want to try and co-locate them.
Yeah. So the same kind of rules really for normal DPF, row level DPF apply here as well, right?
Exactly. Yeah, it's identical. So that's why if you've already got best practices for row-based DPF, same thing is applied for BLU. So this chart we showed last week, but what it does is it highlights the fact that if you're running BLU in a DPF environment, you still get excellent scaling. So the chart on the left is basically a 3-node system went to a 6-node system, same amount of data, but you see you get almost twice the throughput. So that means that as a customer, if I'm saying that I need more or faster response time or I need more throughput, more users, all I need to do is increase my hardware and I get fairly linear scaling. So in this example, we've got almost, like I said, 2 times scaling. The other side to look at it is, okay, I'm going to double my data. So I went from 3 nodes to 6 nodes. I doubled the amount of data, doubled the amount of processors, and I get the same throughput. So very good scaling using DB2 BLU and DPF.
Right.
Okay. This next example is a cloud-based example. So we can do this in cloud environments. So this is running on AWS, which is Amazon Web Services. You could also do this on SoftLayer. Or perhaps you even do this internally, right? You won't provision your own cloud servers. And you'll see that compared to the competition, we do very, very well. So, significantly more throughput than the nearest competitor. All right, so let me explain some of the other things that we've done. So just putting BLU on DPF, yeah, that gave you great performance. And by the way, there were optimizations done within BLU itself to run in an MPP environment. So one good example is BLU does very heavy compression, right? So we get about 10 times compression on the data. The thing is that dictionary, that compression dictionary, ends up being the same on every node. And what that means is that rather than having to uncompress and compare uncompressed against uncompressed, we can ship the compressed data across all the nodes. It remains in its native compressed form, and all the comparisons are done against compressed values. So that means the shipping, the size of the data that gets shipped is compressed. We can use all of the CPUs to do compressed to compressed comparisons. So a lot of efficiency by keeping the same compression dictionaries across the nodes. So that's a key thing we did in order to give you great performance in a DPF cluster.
So George, I mean, the movement of data, it's in between the nodes. It's in columnar format, right?
Right. Yes.
Sure.
Yep. So the data stays in columnar format as we ship data across the nodes. Right. There is no. There's no translation to row or anything like that. And if people weren't aware of this, when DB2 does comparisons, let's say you do a select statement that says select everything from the employee table where the name equals Fred, right? And the thing is, we've compressed all of the names in DB2, so they're only taking up a couple bytes or bits even. So what we do is, rather than uncompress the values and compare them to Fred, we will actually compress Fred, right, into the representation that we use in the dictionary, and then we're comparing the compressed value of Fred with the compressed values in the database. So there's no, we're not uncompressing all the data to do comparisons. So that's a really efficient way of doing comparisons with compressed data, right?
Correct.
Okay. Now, a couple things we did in BLU to improve performance. One of them is I'm going to show you slides on each one of these, but merge is a very popular statement. That means I have a kind of an input table which has new transactions, might have transactions I want to get rid of, or updates. So it allows you in one SQL statement to say, okay, anything that's new, insert into a table. Anything that exists, update these columns, and anything that you don't want, delete it. Okay, and you can do that with one SQL statement rather than even having to write any code. But when we ran this in BLU prior to version 11, it wasn't very efficient. The next one is nested loop join. That wasn't even available to BLU. All right, that wasn't even an option for one of the join algorithms. We changed our parallel sort. It's called a radix sort, which they tell me is the best in the industry, and I don't know how these people keep finding new sort algorithms, but they do. And that by itself has made a substantial improvement in performance. Better sort heap utilization, that's basically internals, how we use the sort space. Less situations where we run out of memory, right, for sorting. A bunch of query rewrite stuff. Push down of OLAP, very important, because, I mean, that's why people use BLU, right? They're doing analytics, they're pushing down sums and calculations and moving averages, and and that stuff needs to sit in the Columnar engine, and not all of it was run in Columnar format, and so that comes down to SQL functions, right, being optimized to work in BLU. So the first one is SQL merge. So now when you do a merge statement, again you have a table that's your source table that tells me what are the new objects. And then I have my target table, which will have the insert, updates, and deletes. Okay, very succinct SQL to do this, and it's very, very powerful. People used to have to write scripts and logic and programs to do merges, and now I can do it like with this one SQL statement. So if you're not aware of merge, I can take you through an entire day course on how to use merge. It's pretty sophisticated. Okay, so what we've done is we've pushed the merge operation into the Columnar engine. And of course, we also do some sorting to make the merge more efficient, right? Because you want to sort by the primary key that you're going to be doing the matching against, and so that ends up being very efficient now in BLU. Nested loop join, as you know, there's hash joins, right? There's other lookup joins. So nested loop join is something now that's supported in BLU. So that makes it yet another option for how we can do joins, right, in BLU. And because we might need to sort, because it's much more efficient in this release, that also makes nested loop join a good alternative to the other two approaches, right, which were hash join and merge join. So here's an example of the sort. As you can see, these were just some queries we run. Just a side note here, my lawyers tell me that you'll never be able to get this performance in your site unless you run exactly our machines with the exact version of what we did, etc. But generally speaking, sort is going to run a lot quicker. And when you think about it, just about everything does a sort, right? Group bys, order bys, right? Rolling averages, everything is a sort, right? So, you're going to get better performance with sort. So here's an example of BLU doing sort in an SMP environment. The next chart just shows you sort in an MPP environment. So in all cases, you're getting significant speed ups in the queries.
Amazing.
Okay. Now here's an example for those people who like SQL, showing you how the pushdown is really helping performance. So in the left-hand side is some SQL, which is hard to see, but the things that are running that take a lot of OLAP pushdown are like the average, partition, over, and rank functions. Those are all OLAP functions now that run in the kernel of the BLU engine. And you can see there's a significant performance speed up, almost 4 times faster, right, because of these things running in the Columnar engine. By the way, you don't have to do anything for this, right? This is just built into the engine. There's no setting you have to do. It's just part of BLU. And so this kind of graphically shows you what the engine is doing to that SQL statement. So the bar on the left-hand side shows you which portion of the work is done in Columnar in version 10.5, and then what's done in the row engine. And as you can see, once Columnar is done, it has to send the data up to the row engine, which then does a sort, does a scan of it, does some work on that data, and then finally returns a result. Whereas in version 11, you see the bar now goes right to the top, and all that work now can be done at the BLU level in the Columnar engine, and then the final step is to return the data to you in row format. So that's really just formatting for you. So by doing this, I've really improved the performance of BLU.
So did you say, George, that you don't need to do anything to take advantage of this pushdown?
No, this is all done just behind the scenes, right? So there's no setting as such.
Okay.
Just install and pay for version 11, and we'll be more than happy to give you better performance, right?
Fantastic.
Yeah. So I should mention, anybody who's on 10.5 and has a service and support contract, they can move to version 11, right?
Absolutely. Absolutely.
Right? And it may be to their advantage too, right? Because especially if you're an Express customer, right, you'll get a license to Workgroup, which means you can increase the number of cores you run on, the memory, the database size is unlimited. So there's some advantages, right? And as you already mentioned at the beginning, you get pure scale, kind of an HA cluster environment included, you get federation included, and you get encryption included. So there's a lot of good reasons for moving to version 11.
Absolutely, absolutely. That's why I wanted to reiterate some of the really the perks from last week that you mentioned. Before you move on, I was just thinking about a scenario where a customer would, who doesn't have too much embedded code, MPP embedded code in their application, if they would be rather better off going for a single instance of MPP compared to BLU with MPP. Have you guys done any results in the lab to show that, like, MPP performance and then versus single partition BLU, when I say single partition, single instance BLU running on a single node, no DPF, and then BLU with DPF?
That's a good question. I don't think we've done anything like that, but I'll certainly research it for you. I mean, there's certainly things that are simplified, right, in a single node. So that would probably end up, I would think, being slightly faster.
So in terms of sweet spots, right? We talked about 10 terabytes up to 20, push it.
Yeah.
And some people have, DPF environment along those lines actually.
Right.
And if there's not too much application rewrite, then it'd be interesting for the customer to see what benefit they could get to collapse the thing instead of expanding it or whatever. So
there's
giving the customer more choice.
Yeah, you're right. I mean, operationally, there's a whole bunch of things, right? I mean, it simplifies my operations because now I'm not dealing with 4 servers or nodes or whatever. I can collapse the operating systems. I can collapse the DB2 instances. So I save on storage. I save on disk. I save on memory. So there are lots of savings that way. The other side, though, is that if you're doing a lot of ingest, right? Then a DPF environment may be better for ingest of massive amounts of data.
Right.
Now, I should, at this point, say that there are some things you need to think about as well in terms of your applications and the SQL that you're using. So BLU obviously can run all of these queries, but the other side of it we haven't talked about is the whole transactional side, right? And that's one thing people need to be aware of, is that BLU can run transactions, but it's nowhere near as efficient as a row-based table. So, if you've got in your DPF environment, if you've got a table there that's, being used for insert, updates, and deletes through transactions or whatever, that's going to be a lot less efficient running as a columnar table. So there may be some tables that you don't want to, translate into columnar tables.
Yes. So do we have the same facility like shadow tables for DPF?
That's a good question. I don't think that's supported, but let me look into that one, Iqbal. This is the first time anybody's asked me a question like that. Yeah.
Sorry to be.
Well, that's your job, right? To question everything. If people aren't aware what shadow tables are, it's a technique where on a single instance, I could have a regular row-based table, and I can define the columns that I want to keep in a columnar table. And what we do is we keep those two tables in sync, right? And we do that through a log process using something called CDC, change data capture. So when a query comes in and it asks for any of those columns, we'll switch over to the behind-the-scenes shadow table, run your query there, where it's going to be a lot more efficient without impacting the OLAP that you're running against the row-based table. So that's certainly something that runs on single-instance BLU. I'm not entirely sure if that's supported in a DPF environment, because there's obviously log issues right across multiple clusters.
Sure. Right? Yeah.
So
yeah.
By default, most IBM answers by default are no, but we'll I'll get back to you on. Maybe we'll have an answer we'll have an answer for our next webinar next week. All right.
Fantastic. Thank you.
Okay. Now, one of the questions that's come up in our chat room here is, are the BLU enhancements being discussed in this session available in single partition databases? Yes, absolutely. Everything you see here is running on single instance BLU as well. So the only thing that's different, of course, is, in DPF environment, I'm partitioning across all of these nodes, but all the BLU push down, the OLAP enhancements, the sort, all of those things are identical on a single instance as they are on a cluster. So thanks for that question.
So single partition with BLU, right?
Yeah, would work just the same.
Yeah.
Okay. Oops, let me go back. Right. So here's an example of another thing that we've done in BLU is inserts into temp tables. So BLU supports temp tables now, and you can load into them in parallel to create declared temporary tables. And you can see that the performance is fantastic. And the more processors you give us, the faster we can do these things. So that's something that's been enhanced in BLU, right? And again, that's for DPF or for a single instance. Here's an example of just a single instance BLU. So back to the question, have things improved? Absolutely. So you'll see there's a couple things that contribute to in this case, 36% improvement is native BLU sort, right? So faster sort. The OLAP functions sitting inside the engine, right? Query rewrite, so this may be using nested loop join, I don't know in this particular example, and more efficient sort heap utilization. So yes, for those customers who are already using BLU on 10.5, they'll see, a significant performance improvement moving to 11.1. Now, I haven't talked much about the Z mainframes, but if there's anybody out there running on IFLs, we do support BLU on mainframes, right? So we run them in a Linux IFL, and we can take advantage of BLU running on the mainframe. Okay, again, it's only on Linux in these IFLs, but you can see there's been significant progress over the last number of releases using BLU on the latest, Z13 hardware. I don't know, Iqbal, do you have any customers running on IFLs?
Yes, definitely. There's lots of customers, and Julian probably who is listening. We have a lot of customer base on the Z platform, and we are trying as well to reach out to customers on for Z Linux. So this will be, I think, this is also a good thing.
Yeah. So we've done a lot of stuff to make sure that this works well on the mainframe. So for any customers out there that's got the they're looking for alternatives, right? Because, we have a box called IDAA that plugs into, the Z mainframe, and it's basically a DB2 ZOS talking to IDAA for fast, warehousing. So it's kind of like BLU in a hardware environment. But for those customers who want a smaller system, they don't want to necessarily bring in a hardware box, they could run a lot of analytics on an IFL running DB2 for Linux with BLU, right? So again, lots of capabilities on the IFL.
Yeah, I think that's really good.
Yeah. Okay, so talking about some of the SQL that's been buried now into the BLU Columnar engine. So I've already mentioned that the OLAP's in there. So these are some of the functions: rank, row number, dense rank, first values, wide rows. What that basically means is that DB2 allows row sizes up to 1 meg in size. Okay, you can declare, let's say, a table, row 1 meg, but it only allows really physically 32K is the largest that can sit on a page. And what we do is we spill the rest. Now, that wasn't supported for BLU Columnar, but now it is. I've got some examples of this in a sec. Also, logical character support. So, this is for comparing character sets that may be more than single bytes. Declared tables, right? Identity and expression columns. We support code HTTP, which is very important, right, for Europe. Not logged initially on tables, and row and column access control for security. So I'm going to show you some details on each one of these. The first one, you notice that all of these functions are now run natively in BLU. Okay, so before, if you tried to do any of these, we'd have to ship it over to the row-based engine to do, and that's inefficient, right? This movement of data. So now this is all done within the Columnar engine, so this is all good, right? Faster results. The extended row size. This is the I call it the lazier developer syndrome. Okay, I know that sounds funny, but what happens is that when you design a table, sometimes you don't know how big a column is going to be. So a good example is a last name. Is it 32 characters long? Is it 64 characters long? In some code pages, we use 4 bytes to represent a character. So Thai is notorious for this, right? In the Thai, almost every character requires 4 bytes. So if you said I'm assigning 32 bytes for a last name, that may only be an 8-character long name in Thai. So when you create these columns, sometimes we pad them a bit. And we see this a lot with Oracle applications where somebody may say, the address, make it 4,000 bytes long, because it doesn't matter, right? Because I'm only going to use 10 bytes or 20 bytes or whatever. But the problem is DB2 did care. Because if you add up all of these 4,000K whatever columns, all of a sudden we exceed the size of a page, and DB2 would say, I can't create that table. So in 10.5, we introduced this lazy allocation thought that said, okay, we know you've designed a table here that's greater than 32K in size, but that's okay. We'll let you define it. When you actually create the row, if it doesn't fit on the 32K size, we'll spill it into a long field. Okay, it's automatic. You don't see it. But it will allow you to create tables that actually exceed 32K that could be up to a meg in size. Now, in Columnar, each column has to live within its size, right? So a character column, varchar, could be 32K, right? And that'll fit on a page. So that's not a problem in BLU. The problem was when you materialize the result, right? A materialized result could be greater than 32K, in which case you'd get a failure. So what we've done is we've changed it so that we allow you to materialize results and define tables that are greater than 32K to BLU. Okay. Okay. And basically, it's just one setting. We say using extended row size, and then you can create, BLU tables that exceed the 32K in size. Right. So that fixes that problem. Character-based semantics basically means that when we see character columns, we could, we'll understand that you're basing it on the character size, not necessarily the byte size. So you can see the difference here. The example says Apfel, which means apple in German. You'll see the special A with the umlaut above it, the double dots or whatever it's called. It's really 2 bytes long. So when we used to do the substring function, we knew that 1 doesn't really mean it's a character. You got to use 2, and it brings back the proper character, right? So we know, we're aware now that you might be having character sets in there that have characters that take up more than 1 byte in size. And what you do basically is when you create the table, you say that you're going to use code units 32 or whatever, and you'll notice you can say that, varchar 20 code units or octets will tell us that there are 20 physical characters in there. They may be 1 or 2 bytes in size, right? So you're just saying I want 20 characters. I don't care whether they're 1 or 2 bytes in size. So that basically you get rid of this issue. Is it, Unicode, is it single characters, is it 4 characters, whatever. We just know there are 20 characters of whatever character size, whatever character set are in there. Okay. Now, query rewrite. This is a big one. And again, this is buried under the covers. You don't have to do anything to see this work. But here's an example of something called a correlated subquery, where you'll notice that I'm trying to find sales, in a set of records that come from the same table or another table, perhaps. You can see, by the way, it's an invalid select statement. I just looked at it. Someone said Celeste, right? It's not Celeste, it's select. Okay, and what we do is we see there's these 2 values that are correlated, and we didn't do this very well in BLU, all right? So what we do is we now do this repeating query. That's basically what's happening. Okay, so for every order ID in the select, we now do this sub-select every time. There's more efficient ways of doing it, kind of like a do loop, right? So what happens is that we rewrite that internally. We use something called a nested loop join. We can use an index if it's available, right? And so this is good for things like updates, case statements. Right? Don't forget updates, right? And merge is part of a merge, right? Or predicates. So that means that all of these types of statements will run much more efficiently now that we've done this decorrelation under the covers. So here's an example of or exists, right? And you can see that on the right-hand side, if anybody uses Visual Explain, it'll show you that it's doing this decorrelation. Okay, this is also very useful for not exists. Not exists was one of those examples where a row-based query could run faster than BLU, right? If you did a not exist. And so this kind of fixes that problem. And here's an example of the performance. Look at that. 46 times, 127 times, 25 times better. So you can look at this in one of 2 ways, right? It's either like, wow, did we ever make this run so much better? Or, wow, boy, you did a crap job in 10.5 with these predicates, right?
There's always room for improvement, I say.
Yeah, we tend to look at it and look how much we've improved it rather than how badly we programmed it, right?
Yes.
Okay, so lots of parallelism as well. We've done a bunch of stuff to increase the performance of like table lookups, index access, nested loop joins. So you may see this with lower latency, more concurrency, et cetera. So this is again all engine-based stuff that we've done, but they all add to better performance. Now, from a security perspective, one thing we added in this release, which I think is actually quite important, is row and column access control. So if you're not aware of this, this allows you to put policies in place for groups of users. So you could say accounts payable is only allowed to see all records associated with the customers who are part of a certain department or part of a certain branch or whatever. And we do this through rules. And what those rules will do is say only these people or groups are allowed to look at these particular rows based on your job classification. And on top of that, we can also mask certain data. So you're not allowed to see values. So you may not be able to see somebody's, say, credit card information. We can mask it out. Or only show the last 4 digits. Or anything that can mask it. So you've got masking and you've got role-based separation. And so this is important in warehousing as well. You may not want people to see certain values in columns. So the nice thing about row and column access control is that it gently changes the data. What that means is that your query won't fail because you're not allowed to do it. It'll just basically return no rows found, or it'll give you 0 data or just portions of the data. So nice way of putting security against your warehousing system.
Right.
Okay, now dictionaries. Now DB2 creates these compression dictionaries for BLU, and they're extremely efficient. The thing is that when we created them in version 10.5, the load process always does it at the beginning, right? It'll do like a certain amount of loading first, uncompressed, while it builds the dictionary, and then once it's built the dictionary, anything after that point in time would get compressed. So the little part of the table would not be compressed, but it's still just a small portion compared to the entire table. The thing is that when you do ingest, insert, and import, if you did that in 10.5, the actual compression, starting off the actual dictionary generation, occurred a lot longer. It took a lot longer to occur right? And so it didn't end up with the most efficient compression. So we've changed the algorithm slightly so it occurs earlier in the process, and it means that it'll create the dictionary earlier on, so you end up with better compression values. Basically, that's what it does. Okay, so that's all of the neat stuff we've done with BLU in version 11. So kind of the key summary things is, one, we've got DPF now, so if you want to use BLU memory columnar, we can do that in a DPF environment. We've also pushed down all of these algorithms and OLAP and improved, performance, so that anybody who's just on a single instance DB2 BLU, they'll end up getting much better performance as well. And that's, like I said, a bunch of stuff involved with that, right? It's the sorting, it's the OLAP down, it's some of the more efficient ways that we do, compression dictionaries. So overall, anybody moving to 11 should see a significant performance benefit moving into version 11 in BLU. The other part of it is, if you are on DPF today in row, you can easily migrate to BLU, but you're going to have to look at what your configuration looks like. Maybe you may have to increase the number of cores or the memory, right, in order to really take advantage of BLU. Or you may want to consider collapsing your DPF system, and that's where you need some expertise like Iqbal and a Triton team to look at your system to say what's the best way of doing this, right? Because you may be able to free up some memory and resources by collapsing your DPF systems. So lots of things to think about. Good thing is you've got lots of options and scenarios for taking advantage of BLU on your servers. So Iqbal, any comments and thoughts about BLU technology?
No, yes, thank you, George. I mean, it was, I think this was a really good deep dive into what's available for BLU in DB211. One question, well, a couple of questions I had. If I have, let's say, if I have a relatively small number, but a huge amount of data, what's the most cost-effective way to use BLU? Is it single partition, DPF with BLU? What are your thoughts on that?
Okay, yeah, that's more of a licensing thing, okay, and licensing is always a dark art, so people should be aware of that. But DB2 is licensed by PVUs, which is basically the capacity of the machine, right, or the LPAR. You can do it by authorized users, or you can do by terabyte pricing. So terabyte pricing may be an alternative for those customers who've got, let's say, a few number of users, so power users, maybe you have 10 users, that's it, and you have terabytes of data. So we allow you to pay for DB2 based on the data side, as opposed to having to license the whole machine. So that might be a very economical way of doing BLU. The other option, too, is, of course, those DB2 Direct licenses. You could just get the DB2 Direct license and use that for your virtual machines or cloud deployments. That may also be a cheaper way of doing it. Rather than doing a capital cost acquisition of the license, you just do a monthly charge, right?
Okay. And so just lastly to end, what editions let you deploy BLU or DPF? Is it just the Advanced Edition now?
Yes, so it's Advanced Workgroup Edition and Advanced Enterprise Edition. Those two products contain everything, and DB2 Direct Advanced license. So the Direct Advanced license contains all of that as well.
Okay, I think that those were the last sort of questions I had. So thank you, George, and I think we'll pass it on to Jules now to wrap it up.
Yeah, great.
Okay, that's great. Thanks, George. Thanks, Iqbal. Very entertaining session, as always, and I learned a lot about BLU, and I'm sure a lot of the people listening to the webcast did as well. So before we go, a quick reminder about the last two webcasts in the series. Next week, that's June the 14th at the same time, 4 o'clock British Summer Time. We've got another session on 11.1, this time focusing on the pure scale enhancements. And then the final one in the series, that's on Tuesday the 21st of June, again at 4 o'clock British Summer Time. We'll be looking at SQL for Converted and looking specifically at the SQL enhancements to ease porting from other platforms. So I hope to see you online then. The recording for this session will be available within the next day or so on the Triton website, and we'll be sending out a link to everybody to allow you to access that. Thanks again for listening. Goodbye.